So I'll try to make this video make a little bit more sense. So what I've got on these two Molex 10-pin connectors here, this wire right here, actually this entire connector is latch pins. I'm on latch 1, which is the display I have doing this hexadecimal count thing. Latch 0, showing the same values in decimal. But I like hex, so we're gonna stay on hex, mainly because it's my cat's name. So this gray wire is the clock signal. The brown wire is data 0. Over here, I don't know if this wire shows up in the video or not, but right here, I guess it does. I have a piece of it's actually Cat 3. It's Cat 3. Goes to a spool, it's down on the floor. On the other end of it, I have the orange pair twisted to itself, so orange, white, and orange are twisted together. I have a jumper wire going between the blue conductor and the green conductor. On this end, I have a jumper wire between orange and green. So I have a complete loop. If I start on this orange-white wire, it'll come back on blue. Alright, so what I'm going to do is I'm going to take the clock wire, which is gray here. I'm going to take this gray wire and unhook it. Of course, that messes up the display because there's no clock. I'm going to take that gray wire. Whoops. I'm going to take that gray wire and I'm going to bounce off my camera. So I'm going to take that gray wire and I'm going to connect it to this orange and white striped wire. Of course, it's picking up some noise, which is making it update, but there's no clock signal yet. It's still not connected. This purple jumper wire I have connected to blue from the Cat 3 loop. So if I then connect that to the clock signal on the Molex, on the KK connector here, there's pin 4 on this connector, you see the display is back to working properly. Until, so I've also got this brown wire, which is in the Cat 3. This white jumper, which is connected to the brown conductor in the Cat 3, which is not part of the loop. If I take that and I connect it to the other data wire here, now my display is garbled. However, it's the clock signal that I'm using, which is the purple wire. That's coming from the original clock circuit that I had created, and it's being clocked at the same time as the 595, which is in front of the display. Now, my theory right now is that the 595 gets the clock, which causes it to shift, so the cascade output of the 595, its data is changing, and if the display clock signal is delayed, the signal that's supposed to be shifting in has changed by the time it actually shifts. That's my theory. So if I take that clock wire, which is purple, which is this one, I change the code and I reassigned one of these pins to be the clock signal, but it updates this one before it actually sends the clock signal out. So this is about 100 milliseconds ahead. Or 1 millisecond, excuse me. Jeez, 100 milliseconds. Yeah, that'd be hilarious. 1 millisecond ahead. If I take this clock wire, which it's interesting that it's still clocking at all. I think it's just picking up noise from the data line as clock. I don't know where that clock is coming from. But this is the actual clock wire. And if I attach it to the advanced clock pin, suddenly my display is back to working. So this does not prove that the delay itself is the problem. As a matter of fact, it almost looks like the problem is more some kind of coupling between the data lines and the clock, maybe, I guess. So while it doesn't prove that my theory was correct, it does seem to show that advancing the clock signal does solve the problem. So, I guess we're going with that.